Assalamu alaikum.
Assalamu alaikum, sir.
Wa alaikum assalam. So everybody fine?
Yes, sir.
Okay.
স্যার আপনি ভালো আছেন?
Yes, Alhamdulillah. Let me. Why my? Uh, Maybe I am getting my voice bad. What is the problem? Okay, I got it. Yes. Now it should be fine. Okay, so I think we have already finished our syllabus in the last class. So today is mainly for open discussion, and some of the exercises we will do hands-on. So everybody please keep your paper and pencil ready so that you can participate with me. We'll first do some hands-on examples from chapter 6, and then if you have any question in the previous chapters also, you can ask me. So please try to come up with some confusion question, but if you ask me to cover an entire section, I think that will be not feasible. So if you have specific questions, then we can discuss in the later part of the theory. I think all of you have already got the final exam routine, right? So our exam is on 6th October. 6th October. Okay, 6th October is which day? It's Wednesday, right? So Wednesday at 2:10 p.m., right? So that is our final exam. So maybe I will give one session, counseling hour session on 5th October, that is Tuesday, probably from 7 to 9 p.m. Okay.
Oh, will
Yes.
you just provide the solution of the last home assignment? Sir?
Yes. I will. When is the deadline? I think its deadline is 30th, Thursday. So after the deadline, I will upload the solution on 1st October. If in case I forget, please anytime send me an email, a reminder, so that I can upload the solution. Okay, and for
Is
those,
there any briefing, any
yeah,
short briefing for the preparation of our final exam?
for the final exam, actually there is no short suggestion. The syllabus is already short, so we have covered selected sections from chapter 3, chapter 4, chapter 5, and chapter 6. See, only 5.2 from chapter 5, only 4.1 and 4.3 from chapter 4. So it's already short. Everything you have to understand, everything. Because there will be no option, as you know, in similar to midterm, there will be no option in the final exam. But you can see our homework questions, all the questions solved in the class, right? Similar questions solved in the class. So everything you get, there is nothing that you need to do your own. Just you need to practice. So please make sure you understood everything. And again, the final exam is uh, assumed to be closed book. So I assume that whenever you start your final exam, you are not looking for any place for searching any place for the solution. That will actually kill your time. That will waste your time. So in that case, that 1 hour 15 minutes will not be enough. But if you take enough preparation, you are prepared like our physical final exam. So in that case, 1 hour 15 minutes should be more than enough. Okay, so just keep in mind. And as I said, those who have still some lackings with the concept, you have to understand the basic example from the textbook first thing, and then you go through the exercises examples that has been solved in the class, go to the interactive websites. Okay, Okay, so before I go to the workbook, let me show you one more example from the interactive website. Okay, so that is our interactive website. Okay, so you can see here in chapter 6 we have covered one example of link layer addressing, and then there are two examples of learning switches. So if you go back to learning switches basic, you can see an example here. Consider the LAN below consisting of 10 computers connected by two self-learning Ethernet switches. Now in this case, the example we have described in the class is extended by connecting one more switch, and the port numbers are different for our understanding. You may want to read it. So if you have any confusion, you go back to 6.4.3, understand the basic example described in the class, and then solve this. But the idea is actually for a switch, if it receives a frame in an interface, it will store a that host MAC address connected to the port where it received the frame. Okay, so at t equals to 0, the switch table entries for both switches are empty. At t equals to 1, 2, 3, and 4, a source ends to a destination as shown below, and the destination replies immediately well before the next time step. So what is being said here, to understand how the switch table is generated, we have to know, okay, whenever one end system sends a message to another end system, just assumption is the receiver will send back the reply. So if for example A sends to E, you will send a reply to A. If B sends to L, see, B is connected to one switch, L is connected to another switch, doesn't matter. Whenever L receives a message from B, L will give a reply to B. So using that assumption, how the table is generated, that is our question. Now assume that the following connections occur. You can see here, okay, how can I make it? Okay, assume that the following connections occur. So at t equals to 1, G sends to L. At t equals to 2, G sends to H. At t equals to 3, L sends to E. And at t equals to 4, G sends to C. Fill out the two switch tables and answer the following questions. Okay, at t equals to 1, what is the source entry for switch 1? Okay, at t equals to 1, what is the source entry? Again, you can use your message box, please, to response, so that everybody can participate and we can connect, and I can relate your solutions and discuss. At t equals to 1, what happens? See, G sends to L. So G is connected to the left switch. L is also connected to the left switch. So what will happen in table 1 and table 1 is the left one, and table 2 is the right one. Okay. Okay. So the question is, what is the source entry for switch 1? That means what will be the entry on the left? Tell me. At t equals to 1, G is sending to L. So what will be the entry?
So 10.
You have to write the MAC of G, right?
Yes, sir.
Mac of G, and then interface 10, right? TTL, you can assume any value. You can assume anything. So in the example we have used 60, you can use 60, no problem. It's all you can use the default. You can write the default value. So MAC address is MAC of G and interface is 10. Will there be MAC of L and 15? Okay, let me check the answer, okay? Check the answer. Okay, I think where is the answer? Okay, anyway, let me show questions. And okay, what it says, you have to fill out the two switch tables. So if I fill out the two switch tables, if G is sending to L, in the question it says a source ends to a destination as shown below, and the destination replies immediately. So that means if I say t equals to 1, G sends to L, then before going to t equals to 2, L sends to G. Is it clear? Is the assumption clear? So based on that, you have to write down the answer. Is it clear to you? Yes or no?
Sir, can you repeat it again?
Okay. Just in this case, you can see t equals to 1 at time 1, G sends to L. But the one assumption in the question is whenever G sends to L, immediately L will reply to G. You got my point? So
Yes,
that is
sir.
not shown here. So before going to t equals to 2, although it shows G sends to L, but because of assumption, L also sends reply to G. So you have to keep in mind. That's fine. That's what I'm saying. So at t equals to 1, G sends to L sends a reply to G. At t equals to 2, G sends to H sends a reply to G. Got my point?
Yes, sir.
At t equals to 3, L sends to E, but it is not shown here. But according to the assumption, E sends a reply to L immediately. So if we assume t equals to 1, G sends to L, what will be the entries? Because L also sends a reply to G. So what will be the entries before t equals to 2? Give me the solution in message box. The question is, before t equals to 2, what will be the entries in switch 1? Give me the answers. You can write like MAC of G. But if in the question I give the MAC address of G, then yeah. Okay, Muhib, from Muhib I got one answer. That is, Muhib says it will be MAC of G and the interface will be 10. TTL actually doesn't matter. It can be the default value. And it will be MAC of L with 15. Any other answer? I need some answers before I move. Okay, Shojol says switch 1. Yes, for switch 1, MAC of G and 10, MAC of L and 15. Okay, Shojol, next. Any other answer? See, if you participate now, you will be done. Not participate, okay, you have to study yourself later on. MAC of G, 10 TTL, Fahad. Okay, MAC of L, 15 TTL. One more answer, then I will move. One more answer. What about Pratik, Rakib, Anand? Tasina, some of you, many of you are not participating. Okay, Rakib, Mac of G and the Mac of L. Okay, I think all the answers are correct. Very simple. When G sends to L, then Mac of G will be entered because the frame will be received at interface 10, if you can see. And when before t equals to 2, it is being said that L will send a reply immediately to G. So Mac of L will also be there, but in that case, interface will be 15. So that will be just for t equals to 1. For t equals to 2, G sends to H. So again, both in the same network, same segment. So it will be G equals to, again 10. So D equals to 10 already there. Mac of G is already there. So no change. When G sends to H, for the first case, no change. When H replies to G, then there will be what? Mac of H, and then that will be 11, right? Interface will be 11. So that is after t equals to 2. After t equals to 3, L sends to E. So L is connected to switch 1. Now E is connected to switch 2. So where will be the change? Anyone? Okay, for t equals to 3, not 2, t equals to 3. L sends to E and E will immediately send reply to L. So what will be the changes? Write down the name of the switch and then the entries. Give me the answer in message box. When L sends to E, L is connected to switch 1, E is connected to switch 2. And then E will send a reply immediately. What will be the entries in switch 1 or switch 2 or both? I got answer from Muhib. Please, others, please participate. Your answer may be wrong, but that will help us to discuss. So Muhib says in switch 1, already G10 is there, already L15 is there. And when H11 is there, so L is already there. So you don't need to put L, right? And when L sends to E, then there will be an entry. Okay. Any other answer? Because now in this question at t equals to 3, we have a new scenario where multiple switches are involved. So from L to E, when L sends the frame through switch 1, L15 is already in switch 1, right? No problem. But that frame will be forwarded to which interface in switch 2? Muhib? When L frame from L will be forwarded from switch 1 to switch 2, which interface switch 2 will receive?
8. 7.
No.
7.
7. So switch 2, shouldn't switch 2 also create a row for L?
Yes, sir.
So there will be L7, right, in switch 2. L7 also, because switch 2 is receiving the frame from L. Now what is interesting here, from any node in switch 1, when switch 2 receives, it will assume that that host is connected to 7. So all the hosts in connected to switch 1 will be assumed to be connected to port 7, and that has no problem, because whenever the destination is anyone with switch 1, switch 2 will reply to 7, no problem. Switch 1 will then decide. So that's again, logic is very simple, although there are multiple switches. So at the end of T3, when L sends to E, I think Muhib's answer is almost correct. But in switch 2, there will be another entry, that is L7, right? in switch 2. Agreed or not? Others? When switch 2 receives the frame from L, there will be a new entry in switch 7 with MAC of L, and then interface will be 7. Is it correct or wrong? Please participate, otherwise we cannot progress. Is it correct? L
Yes, sir.
L with 7. That is actually switch 2. This is switch 2. Okay. So there will be one more entry, L7. Now that is for L to E. Now E will immediately send a reply. So as Muhib's answer, E5 will be there. And then there will be another entry added to switch 1, right?
Yes, sir. It will be E8.
Very good. Very good. E8. So if you understand the logic, it's very simple. So now switch 1 will have 4 entries and switch 2 will have 2 entries. If you go to T equals to 4, G sends to C. Again, G is connected to switch 1 and C is connected to switch 2. The same procedure. Okay. So what will happen now? Let me, so you can answer all the questions. I'm not going through all the questions, but if you see the solutions, actually, if you have done the entries of switch 1 and switch 2, you can easily answer all the questions. For example, at time T equals to 1, G7 is added as an entry. G7, right? What we say? G. Okay, I think there are some problems in this answer because G is connected to 10. It cannot be G7. Which one is switch 1? Switch 1. So switch 1, I am assuming switch 1 is left one. Okay. So if switch 1 is left one, then G10 will be
Sir, G7 in switch 2.
right, G7 in switch 2. Okay. Actually, no, G7 will not be there because G is sending to L. So G and L is connected to the same entry, right? Same switch. So there is no possibility of G7. I think this they have done wrong. This is don't worry about this answer. If you find anything confusing, you can just take the screenshot and send me an email. I will make it clear because they have continuously they are being updated this website. Okay, so maybe there can be some mistakes. Just don't blindly follow the solution. If you find anything confusing, take the screenshot, send me an email. In this case, after T equals to 1, G is sending to L. Why there will be 7? Because G is connected to 10, L is connected to 15 with the same switch. So the entry, the answer given here at time T equals to 1, G7 is added. It's wrong. Okay. Now at time T equals to 1, G7 is added. G10 is added to switch table 2. So now they say, what is the source entry for switch 2? Format your answer. Now, which one is switch 1 and which one is switch 2? That is a question. I'm assuming the left one is switch 1 and the right one is switch 2. So don't worry about this. If you think about left one is switch 1, just follow your with your solutions. Because in this case, they say, what is the source entry for switch 2? And for answer 3, now they say G10, L15. Okay. So maybe they are assuming the left one as switch 2 and the right one as switch 1. But just use your own concept. Okay. So I think this is clear. Just don't, if you understand how the table is filled up, then it is easy to answer every question. Don't worry about the individual answers of the question. But did you understand the concept, how the switch is actually generated? Is it clear now? Any question, anybody? Okay, no question. That means you are 100% clear or you are 100% not clear. I am not sure because you are not saying anything. So let me move to workbook. Let me move to workbook. So many of these concepts we have already discussed, the same thing. And then, okay, one thing, CSMS CD, I am omitting. So don't worry about the CSMS CD part in the CSMS CD part in the workbook, okay? Because, oh, sorry. Okay, so the CSMS CD part will not be there. So this part you can, oh, sorry. This part you can omit. And this exercise 3 you can overlook, okay? Now this we have covered, and just now this we have discussed. Link layer addressing, I think we have solved this type of problem where there are different switches and routers are connected. So let me solve one. There are some pictures that will make your concept much more clear. So these pictures I have taken from other sources like uh, Cisco materials, CCNA courses, just to make our concept more and more clear. So for example, in this diagram, you can see there are two PCs connected through 3 routers. So whenever PC 1 sends any data to PC through 2, that must be forwarded to router 1. Okay, and router 1 says my ARP table tells me that PC2 uses MAC address of this. Okay, and then actually it is not PC2, it is a router 2. So it will forward to router 2, and then router 2 will forward to router 3, and then finally router 3 will forward to the final host. The same concept, but this is a different diagram where you can see the ARP cache at the same ARP table. At the same time, you can see the routing table already we have done in chapter 4. Okay, this example we have already done in the interactive exercise. I can just ask you questions from my view. Okay, so I am using the same thing, but we have discussed this. Let me ask you one question. Why ARP protocol is needed? See textbook. You have to give the answer. I'm not giving the answer here. Now, question 2. Consider an ARP request. See the ARP request sent by node C. Sent by node C. Actually, we will consider a node, sending node as C to A. There is a little mistake here. It should be C to A according to the question. So C sends a frame to A. Now, the second question says C sends a frame to A. So we have already solved in the last class. This is the points it will travel 6, 4, 2, 1, right? So the second question says, consider an ARP request sent by node C. Why ARP request? Because C's ARP table is empty. Suppose assume C has no entry for A or for the router. So definitely C will send the ARP request. It will broadcast an ARP request. Which IP address will respond to the request? Give your solution in the message box. So this type of questions can be in the final exam also. I can give a scenario, and based on the scenario, I can ask you any question for IP address, MAC address, ARP, switch table, okay? Which IP address will respond to the request? I want to see the solution in the message box. Did you get my question? Are you in the class? Am I online? I'm not getting any response
Yes, sir.
from you. Okay, only Muhib is giving some response. No one else. Everyone. I'm not sure what you are doing. You are not asking any question. Okay, Shajol gives one answer, 128. Rakib gives one answer, 128, 119, 98, 146. 98, 146. So what is the IP address? Whose IP address is this? This is the IP address of host C. See? But my question was, which IP address will respond to the request? ARP request sent by node C. Should C sends ARP requests to know its own MAC address? Yes or no? Email says host D. Why host D? Because the question says C is sending data to host A. There is no place for D. C is sending to A. Muhib says 128, 119, 98, 239. And this is the correct answer. Basically, this is the IP address of the port of the router. See, when C sends a data frame to A, C will know A is in a different network. So C needs to forward the data frame to home, to the router, right? So C will run an ARP protocol to know the MAC address of router. We know the ARP protocol, right? How it works? C will broadcast an ARP request. What will be the destination MAC address? Okay, that can be another question. What will be the destination MAC address of the ARP request sent by node C? You got my question? What will be the destination MAC of the ARP request sent by node C? Anybody? We have just read this ARP protocol, how ARP works. We have seen there are 3 or 4 steps. And the first step, if a node doesn't know the MAC address of a particular IP, then it will prepare a ARP request and it will broadcast to every member of the segment. Then the node which has the same IP address, the destination IP address mentioned in ARP request, will create a response with its own MAC address, right? That is how ARP works. Okay, so what is the destination MAC for the ARP request sent by node C? No answer? Okay, I am not giving the solution right now. It's your duty to find the answer. Because you're not participating. So the answer of this question, to understand the answer of this question, you have to understand the ARP protocol. And then ARP requests broadcasts to everybody within the segment. In this case, since destination is in a different network, we know the default gateway. I have mentioned several times that in this case, C, okay, I still, Muhib, I got your reason. You are absent in the Saturday class, but still you are giving the most of the answers. So that means those who are present in the class, maybe I'm not sure, followed the lecture correctly. Anyway, so if destination is in a different network, then definitely C will send the packet to router. This is a very fundamental thing. Many times we discussed about this. Fahad, you said C MAC address. No. No, C is the source. C is the sender. It knows its own MAC address. No big deal. Why ARP is needed? Okay, so I mentioned 2 cases in the lecture. Case 1, when destination is within my network. Like if C sends to D, there is no need for router. Yes, I think Shajol, you are correct. MAC of 0.4. You are correct conceptually. But just to reminder everyone that we have covered two cases. One is where destination is within the same segment. You don't need any router. In that case, that destination will respond to the request, ARP request, because that also receives the ARP request in the same segment. But if destination is in a different network, then destination will never receive ARP request, because ARP request will broadcast, and broadcast will contain only within the segment. And in this case, due to default gateway, we don't need to know the MAC address beyond the router. So that's why when C sends an ARP request broadcast, everybody will check, but router's MAC will be returned. Router will return the ARP reply because router will match its own IP address. Okay, so the question actually asks which IP address will respond. Simple. Router's IP address will respond, because in the ARP request, if you can remember, in the ARP request, IP is known, MAC is not known. So that IP is included in the request. So those who receive the request can verify, okay, is this IP for me? My IP matches? Yes, it matches. Then I will reply. It doesn't match? Drop. No need to reply. So when all the nodes, including D, router, and other nodes, all receiving this ARP request from C, but only router will reply. Why? Because in the ARP request, C has mentioned the IP of the default gateway. Then what is the default gateway IP? That is the IP of the router. So router can verify, okay, this is my IP, so I need to respond. So router will respond with this MAC address. And then after receiving the MAC address of router, C will forward the frame to the router. It will not forward directly to A. Okay, then router will do the rest. So I think we have covered in details the same thing. Somewhere you have to understand the things. Anyway, question number 3 says, now the ARP table is filled up for the data packet from C to A. What are the MAC source and destination address and IP source and destination addresses in different points? I think this we have solved in the last class, yesterday's class. So it should be clear to you. Okay, one last thing. This again you have to try exercise 2, because this all we have solved. Just one more problem I want to solve before I take questions from you about the topics of inter-syllabus. Question number 7 in the knowledge test. This question actually merges the concepts of switch responsibilities, ARP, IP address, MAC address, router, switches. So all the concepts are here. And based on the concepts, it will ask the question. Okay, now let us solve this. Question 7, consider figure 5.33. This is actually from the textbook, okay? And you can see it says in this diagram there are two routers. So you can say this is router 1, this is router 2, okay? This is maybe switch 1, switch 2, and then switch 3. Okay? And how many subnets are there in this diagram? How many subnetworks? It is already said here, but I am asking you, how many subnetworks? Himail says 4. How 4, Himail? Shojol says 3. Actually, there are 3 subnetworks, because you can see 2 routers. The switch 2 connects 2 routers and the 2 hosts C and D. So this is one subnetwork. And yes, Himail, that's correct. So 3 networks, and switch 3 represents one subnet, switch 1 represents. In fact, in this diagram, switch 1, switch 2, switch 3 represents each of different subnets, because they are separated by routers. So 3 subnets. Now, one change in the diagram is suggested by the question. Replace the router between subnet 2 and 3 with a switch S2. So what is the subnet 2 and 3? See, this is subnet 2 and this is subnet 3. And what change they have proposed? Remove this and add a switch here. Okay, so this is the sign of switch. So add a switch here, and this, they say this is switch 2. So let me make this switch 4 and this is switch 2. Actually, they did not mention the other switches because maybe those are not needed. But for understanding, I have numbered all the switches. Now S1, S3, S4, just for making compatible to them, replacing the router, we add a new switch in place of router. That means switch 3 should be connected to it. Switch 4 also should be connected to it. This is switch 2. So now, what is the major change? Anybody? What is the major change in the diagram in terms of number of networks? Anybody? What is the consequence? What is the impact if we replace a switch by a, replace a router by a switch? What is the result? Consequence?
Sir, subnet একটা কমে যাবে.
Very good, Shajal. Very good. So actually subnet 2 and 3 will merge now to a single subnet. Right? That if you understand the IP addressing subnetting, I think this is very simple. So now there will be two subnets. One is subnet 1 on the left, and then one is subnet 2. So two subnets will be in result. One is subnet 1, that is subnet 1, and another one will be subnet 2 and 3 merged. Okay, so everybody clear? I think this is if this concept is clear, then you can go for the answers. Any question, anybody up to this point? So if we replace, we could have, I could have asked you, I could have changed the question asking like the same as it is, R1 and R2, or I could have asked you like change R1 router, not the R2 router. So these are the modifications I can do, but the concept is same. Okay, so now come to the question. First question, consider sending an IP datagram from host E to host F. Host E is here and host F is here. Okay, will host E ask router R1 to help forward the datagram? Yes or no? Use your message box. Mainul says no, Himail says no, Tanvir Semanik says no, Pratik says no. Very good. So this is, I think, clear to most of you. So it is no. And for others, I know many of you not being connected here. You are in the class, but you are not connected with me. So that is a problem. I have no solution for that, because if you are not participating, it's very tough to get your participation. So that's why just try to get engaged from somewhere. Don't worry about, okay, I did not participate in the previous cases. Just try to engage somewhere, although this is the last class. But throughout all the trimesters, I have just tried to make you participate. Maybe if you participate, your 60-70% concept will be, not only concept, your preparation will be done in the class. That's what I always try. So that's why those who are not participating, maybe you will not have clear concepts. You have to do it your own. But if you participate, it will be simple. So everybody gives no. That means since both sender and receiver in the same network, same segment, we don't need any router. Very simple. The why, you can answer the why part also, because they are in the same segment, so we don't need router. Now in the Ethernet frame containing the IP datagram, so we know the frame contains an IP packet from the layering, we know that. Now the question asks, what is the source and destination IP and MAC address? Can you write down source IP, source MAC? Yes, I got an answer from Mohib. Please, others, please participate. Try to give your own solution. So the question says, E is sending a frame that will contain a packet. So frame will contain source MAC, destination MAC, and packet will contain source IP, destination IP. Now the question asks, and it's a simple one because they're in the same network. What will be the source and destination MAC and IP addresses in that frame? So source IP will be definitely E of IP, right? IP of E. So source IP will be IP of E and MAC of E, same thing. And destination will be IP of F, and destination also will be MAC of F. So this is actually simple. This because E and F in the same segment, that's why. Clear? Anybody has any confusion, any question? So both IP and MAC will be, source will be E, destination will be F, because there is no change of links. This is a physically same link. Although there is a switch in the middle, we told you many times, switch will not change anything. Yes, Manik, IP of E, MAC of E, IP of F, MAC of F. Okay. Then the second question. Suppose host E would like to send IP to host B. Now, host E sends an IP datagram to host B. So if in the diagram you can see host E and host B, they are in the different network, right? So you know what will happen? Definitely host E will send to router, and then router will send to host B. Assume that E's ERP cache does not contain B's MAC address. Okay, so maybe ERP is empty, or at least it doesn't contain any destination MAC address. Will E perform an ERP query to find B's MAC address? Yes or no? Again. Mohib says yes. Now I am getting all the answers as yes. Pratik, Anand, yes. Very good. Participation is more. But just see a little bit of trick in this question. It says, it doesn't say, will E perform an ERP query? Your answer is perfect. Will E perform an ERP query? Your answer is perfect. Will E perform an ERP query to find the router's MAC address? Your answer is perfect. But if it says, will E perform an ERP query to find B's MAC address? Not feasible. Why? Because B is in a different network. We have mentioned many times, the ERP only works within the segment. So the last part of the question makes this no, not yes. Is it clear? Mohib, Mainul, Manik, Tanvir, Pratik, Anand. I think your answer is in one sense correct, because you think about whether ERP query will be performed. Definitely it will be performed. But the question also added to find B's MAC address. No, B's MAC address you will never try to achieve. So that's why the answer will be no. And the explanation why? Because B is in a different network. So B's MAC address is not feasible to be, or you can say E will never request to find B's MAC address. Okay. Now in this case, let me explain again the idea of default gateway. Before ARP request is made, before ARP request is made, because this is in data link layer, we have already covered in network layer, right? So network layer decides the thing whether destination is in a different network or in the same network. So that is done first. Already that is done. And when destination is in a different network, what we do? Forward packet to router. Forward packet to router. So it is already been decided by the host E that destination is beyond my network, so I cannot directly send to B, so I have to send to router. That is the default gateway idea. So that is already done. So now there is no scope of E being asking for MAC address of B. So this is all concept. So E already decided I have to forward to router 1. So it will definitely ask for the MAC address of router 1 because default gateway IP is given in E, right? When we configure, we give IP address, subnet mask, and also default gateway. So it is known to E. So whenever it creates an ARP request, the destination IP will not be the IP of B. See, this can be another question I can ask. When preparing the ARP request, will host E include IP of B as the destination IP? Maybe you can say yes, because IP of B will be always the destination, but not for ARP request. For ARP request, destination IP cannot be IP beyond the network. If beyond the network is the final destination, then router's MAC will be, router's IP will be the destination IP for ARP request only. See, ARP request is not the real data frame. The real data frame needs destination MAC. That's why we use ARP request. I think in my previous 2 lectures, many times I have mentioned this. So you know why? Because B is in different network. It will not ask for B's MAC address. Rather, it will ask for router R1's MAC address. Now, the last part of the question, in the Ethernet frame containing the IP datagram destined to be, that is delivered to router R1, what are the source, okay, and destination IP and MAC address. Again, please write down this. In the frame destined to be from router R1, what will be the source and destination IP and MAC? Okay, Shojol, I got answer from Shojol, IP of E and then MAC of little bit problem, Shojol, in the answer. Destination will be IP of B and MAC of R1. No. Source IP of host E and MAC of E. Anand. No, not yet. Correct answer. Okay. See the question again. In the Ethernet frame containing the IP packet destined to be, who will send that packet? Oh, sorry. That is delivered to router R1. I'm sorry. I made the mistake. Sorry for that. Actually, that is not from R1 to B. I thought it is R1 to B. Actually, it is from E to R1. So Shojol's answer is, I think, correct. Because it says that is delivered to router R1. But if I say that is delivered to B, definitely that is by router R1, then the answer will be different. But since that is delivered to R1, so it is E to R1. So for E to R1, source IP will be IP of E, destination IP will be IP of B, definitely the final IP. Source MAC will be MAC of E and destination MAC will be MAC of R1. Anand, not MAC of E, MAC of, okay, source will be fine, MAC of E, but the destination will be IP of B and destination will be MAC of R1. Very good. Okay, Mainul, the same thing. Source will be MAC of R1. Okay, if it's from R1 to B, I think Mainul, you have given answer. If I say from R1 to B, but in the question it says from E to R1. So that's why you have to carefully observe what the question asks. So if you have the concept, clear concept, you can grasp the question. If you have just the surface level concept, you are not sure what to do, then you will definitely do mistakes of extracting what the information was asked in the question. Okay. Question C, the last one. It says, suppose, now this is actually just from a different angle. Suppose host A sending to host B. Again, host A and host B, if we see, Host A and host B, they are in the same network in subnet 1. Just keep in mind. And they are connected with a switch called S1. Just that's why I have numbered this. And neither A's ARP cache contains B's MAC address, nor does B's ARP cache contains A's MAC address. So nobody has, like you can assume all ARP table are empty, okay? And further, suppose that the switch S1, see, I have correctly numbered this S1, switch S1 connecting A and B. Connecting A and B, forwarding table contains entries for host B and router R1 only. Now, this forwarding table is what? This is actually the switch table or the MAC table, right? So it contains entries for host B and router R1 only, which okay. So entries for host B and host. That means if you just draw the table here, switch forwarding table contains what? MAC and then interface, right? So it has entry for B, it has entry for router R1 with the corresponding interface. Okay, so that is given. Now, since there is no entry for ARP, so A will broadcast an ARP request message. From this point, you have to answer all the questions. What actions will switch S1 perform once it receives the ARP request message? What do you think? What action switch S1? I'm sorry, this should be switches MAC table. I'm not. It is not R1. This is switches MAC table. So switch table. Okay. And first question was asked because A is sending a ARP request. A is sending an ARP request so that it will broadcast that ARP request. Now, what switch will do? In this case, you have to know the flooding action. Can you remember that yesterday I told you the flooding action means when there is a broadcast frame, switch will flood all the interfaces except the incoming interface. Right? Did I mention that in the last class? Yes or no? Yes or no?
Yes, sir.
I have mentioned it yesterday that, so in this question, actually we have merged all the concepts. So you have to know the concepts very well to answer this type of questions. What actions will switch S1 perform once it receives? Actually, this is not about ARP request. This is about a frame, broadcast frame. When switch receives a broadcast frame, what is the destination MAC? Anybody? All F's, right? Is it right? ARP request is a broadcast message. So what is the destination MAC? All F's, right? All F's. So when switch receives, see the question asks what action switch will perform. So actually it is not about the ARP. It is not about the other protocols. It is about what switch will do when it receives a layer 2 broadcast frame. It will just send to everybody. Okay, so that is the answer. It will flood, it will broadcast to every device in the segment. That is the answer.
স্যার সাবনেট 1 এর সবাইকে সব হোস্টকে পাঠাবে
Right. Subnet 1, of subnet 1, definitely of subnet 1.
তাহলে স্যার রাউটার তো স্যার তাহলে কোনো রিকোয়েস্ট পাবে না
Router will also receive because router is part of the subnet, right? Router is also part of the subnet.
R1 যেটা ওটা ডিফারেন্ট সাবনেট না
No. R1 is connected to subnet 1, right? So the interface of router that is connected to switch is also part of the subnet 1. Is it correct?
Yes, sir.
So the ARP request will be received by whom? Now that can be another question. Who will receive ARP request? Then except A, all other nodes in the network will receive the ARP request because this is a broadcast. So router will receive, B will receive. If there are 3 other nodes, they would have been also received. Okay. So the second question, will router R1 also, okay, this is the question. The same thing I have also already answered. Will router R1 also receive the ARP request message? Yes or no?
Yes, sir.
Yes,
Yes, sir.
definitely. Definitely, because this is part of the same segment. If so, will router R1 forward the message to subnet 2 to the other subnet? Will it forward? Mainul says no. Any other answer? Tanvir says yes. Why, Tanvir? Why it is yes? Abu Kalam says no. Actually, this is no. Again, let me clear one more time. There are 2 types of data when we go think about ARP. The original data frame. The original data frame. To know the destination MAC in the original data frame header, we actually run ARP, right? So ARP is not the data frame. ARP is a special protocol. So for the normal data frame, router receives frame from one side and router forwards the packet or frame to the other side, right? For normal data packet, router forwards the data packet, but router will never forward the ARP message. Never. Keep in mind. So this is ARP request. So the answer will be no. Is it clear? Because ARP request will not be forwarded beyond a subnet. Okay? Is it clear?
Yes, sir.
Simple. ARP request is not normal data packet, so it will not be forwarded by the router. And once host B receives this ARP request message, host B, definitely host B will also receive, right? It will send back to host A an ARP response. This is understandable because B's IP will match. So it will know that, okay, I have to send back an ARP response. But will it send an ARP query message to ask for A's MAC address? That is another conceptual question. Now, A needs B's MAC address. So A sends the ARP request. B also needs A's MAC address, right? Is it right? Because B needs to reply. So B also needs A's MAC address. Now the question is, will it send a new ARP query message to ask A's MAC address? Yes or no? What the logic says. Okay, let me ask you one question. When B receives the ARP request, did that ARP request contain the MAC address of A as the host MAC address? Okay,
Yes,
let
sir.
me ask you again. When A sends a ARP request, right? A's MAC will be there, right?
Yes, sir.
Definitely. So simple logic. B already knows the A's MAC address, and that is why when when the ARP works automatically, or when switch MAC table starts automatically, within a fraction of seconds, it knows everything. Why? Because of these simple things. Since A's ARP request contains A's MAC address, B already knows A's MAC address, so B will not send a new fresh ARP request to A. Right? Clear? So the answer will be no. And you know why? I have already given you the explanation why. Because ARP request from A contains A's MAC address as the source. A sets its own MAC address as the source, but A does not know the MAC address of B. That's why it sends ARP request. But when B receives the request, we already know, okay, this is this is from A. So A's MAC address is this. And then it will not send a new query message. Okay, clear? Any question? Okay, last question. What switch S1 will do once it receives ARP response message from host P? Now, before answering this, will ARP response be a broadcast or it will be a unicast? That is the question. Logically, what do you think? It should be only sent to A or it should be sent to everyone?
Send to everyone.
Okay, Fahad, we have to think a little bit. Shajal says unicast. That means will only be sent to A. Actually, see, A, yes, Anand says unicast. So A is sending the request, right? A is sending the request. So A will only receive the response. A is broadcasting because A does not know who is B, who is this IP address. That's why broadcast. But when B prepares a response, B knows that is the requester is A, and A's MAC is known. So that should be unicast. That should not be broadcast. Okay. So if that is unicast, what switch will do? It will selectively forward to the interface to which A is connected. So there is no interface number here, but we have solved a problem, right? Selectively forward, selectively forward, when switch table contains the destination, possible destination, then it will forward only to that particular node. So the answer will be S1 will selectively forward. Selectively. So now it will not flood, right? Selectively forward to A's port. Actually, not A's port, it's the port of the switch that is connected to A. Clear?
Yes.
So I think those who have the basic concepts clear understood this 100%, but those who are yet to understand the basic very clearly, maybe you thought you will see later, you will learn later, you will see my lectures, you will see textbook before the exam. So at that time you will understand the concepts. For those actually, unless you understand the basic concepts, it's very tough to understand this right away. But again, all the lectures recordings are there. Although I always prefer if you can at least get the basic things done in the class, then outside the class you will practice with some examples. But understanding the basic concepts, class is the best place to make it clear. Okay, so that is the last question. I tried to, in fact, in this question, all the concepts of switch table, router, IP address, MAC address, and then ARP, all the concepts are merged into a simple scenario. So if you understand the answers of this, not answers of this question, the concepts of this question, then I think any question you can answer, any this type of question. Okay, now in the last part, I will now take your questions or confusions, but specific, be specific. Any question on chapter 6 first of this solution or any other? If not, all of you, because I have mentioned during the start of the class that there is no short suggestion. Everything you have to understand, because already the syllabus is short. I have covered the selected sections of chapter 3, chapter 4, and also for chapter 3, I think up to 3.3 is covered, right, in the midterm. Oh, up to 3.4, right? What we have covered up to 3.4 or up to 3.3?
3.4.
3.4. So 3.4 is covered. So only 3.5 and 3.7 in chapter 3, then 4.1 and 4.3 in chapter 4. Only 5.2, that is algorithms in chapter 5, and then 6.1, 6.3, and 6.4. Even in 6.4, we have covered only 6.1, 4.1, and 6.4.3. All sections I have mentioned in slides and also in your workbook. So it should be no confusion. Okay, so any question, anybody from the entire thing, from the syllabus, from the exam, for the exam, for any other issues?
স্যার মেইনলি তো লাইক ওয়ার্কবুক থেকেই লাইক লেকচার আর ওয়ার্কবুক থেকেই তো প্র্যাকটিস করলে হয়ে যাবে তাই না?
Lecture workbook. Actually, I have taken some questions from interactive exercises to the workbook. But
আচ্ছা
if you go through the interactive exercise, you can find similar examples, more and more similar examples. So that is nothing new set of problems, similar problems, but you can practice more. And those are interactive also. You can see the questions, you can see the solutions. So those will help.
ওকে স্যার।
Okay. Okay, so any other question?
ক্লাসে আসছিলাম কিন্তু আমার নেট চলে গেছিল মাঝখানে।
Okay, just send me an email.
Okay.
I'll check. Okay, let me stop the presenting. So no more question. You want to find questions in the preparatory, don't worry. As I said, if you find anything problematic, you just can send me an email, or I will give one counseling session. It will be just before the exam day, because if I give much earlier, then many of you by that time did not finish the syllabus, so that actually becomes not much effective. So that's why the counseling session I will give on 5th October from 7 to 9, and I will update in the ELMS, and also I will try to post your marks without final exam in the ELMS by 2nd or at most 3rd October. So if you see any discrepancies in the marking, you can send me an email or you can check. One more thing is those who have mailed me earlier with valid reason for COVID issues, for family issues, and for other valid reasons, only those who have mailed me will appear a makeup class test. Already I have created the class test in ELMS, but that will be held on tomorrow at 8 p.m. Please don't miss that. Those who have mailed me earlier, that will be counted as a makeup for you, but only for those who have mailed me earlier. So if others appear, actually I will not count. Okay, so any other question? If not, then let me take the attendance. Okay. Okay, Raihan Chaudhuri. Himel Mojumdar present. Shaheen Alam.
Yes, sir.
Okay, Tarek Mahmood. Arafat Rahman. Tasnim,
Yes, sir.
Okay, Arafat present. Tasnim Faria. Khushnur.
Sir, Tasnim Faria present.
Tasnim Faria present. Khushnur.
Yes, sir.
Okay, Sajib Kumar.
Yes, sir.
Mohimul Bador.
Present, sir.
Tauhidur Rahman. Karishma Haq.
Present, sir.
Okay, Mohammad Abdullah.
Yes, sir.
Shahriar Jaman.
Yes, sir.
Mahbub Rahman.
Sir, Tauhidur Rahman present, sir.
Tauhidur Rahman present. Okay. Khondokar Mahmudur Rahman.
Yes, sir.
Nur Hussain.
Present, sir.
Tahsina Safa.
Yes, sir.
Sumaya Haq. Sayyeda Muntaha.
Present, sir.
Rajia Sultana.
Yes, sir.
Mahmudul Hassan,
Present, sir.
Abdullah Al Fahad present, Pratik present, Sabbir Hussain,
Present, sir.
Farhana Akhtar,
Present, sir.
okay, Manik Hussain present, Saleh Akram,
Present, sir.
Ahmad Musa,
Yes, sir.
Hassan Shaun,
Yes, sir.
Mainul Karim present, Muhib Al Hassan present, Nazma Akhtar,
Present, sir.
Millat Hussain,
Present, sir.
Ahmed Raihan,
Yes, sir.
Jahidul Islam,
Yes, sir.
Shahparan,
Yes, sir.
Tahalil Azim,
Present, sir.
Anisur Rahman,
Yes, sir.
okay, Mohammad Tanvir,
Present, sir.
Ridwanur Rahman, Imran Hussain,
Yes, sir.
Mirza Salem,
Yes, sir.
Anand present, Ashikul Islam,
Yes, sir.
Yusuf Ali,
Yes, sir.
Abu Kalam present, Shajol present, Rakibul Islam present. Okay, anyone else? Okay. Okay, so thank you very much. As I said, I am always available through email, and I will give one counseling session just before the exam day. But by this time, if you face anything, just send me an email. I'll try to help you.
স্যার
Yes.
স্যার CT5 তে আমি স্যার ওই সেকশনে দিয়েছিলাম স্যার
Okay, just when I give you the marks, just if there is any discrepancy, then just report that. Okay, send me an email
Okay, sir.
that time. I should add these your marks to section D. Okay, thank you very much. Have a nice preparatory good preparation for the exam. Best of luck.
Thank you, sir.
সবাই ভালো থেকো, আল্লাহ হাফিজ।
আসসালামু আলাইকুম স্যার।
আসসালামু আলাইকুম স্যার।
ওয়ালাইকুম আসসালাম।
আসসালামু আলাইকুম স্যার।
ওয়ালাইকুম আসসালাম।
স্যার।
ওয়ালাইকুম আসসালাম।
এটা তো স্যার আমাদের লাস্ট ক্লাস না স্যার?
Yes, this is officially our last class.
ওকে স্যার।